Hello everyone, welcome back to the workshop. Today, 1 week after its arrival in the shop, I am finally ready to show you my new Robertson number 4 power hacksaw. This machine, you might be able to see, I've already used it quite a bit. Whenever it first came to me, it was a 7-hour road trip to pick this saw up. A lot of the features were frozen. It was rusted, it was oily and greasy, the clutch didn't work, and it looked okay-ish, but it definitely needed cleaning, and that was the first thing I did. I tore it apart, I cleaned all of the mating surfaces, looked at all the bores, I checked the bores for slop, and almost every bore on this machine is really good. None of them are wore out too bad. The two worst bores on here are the bores for the connecting rod. They seem like they didn't get a lot of oil, but every other bore and eccentric is pretty dang good. This saw boasts an 8x8 capacity, which is about what I want in a hacksaw. It's big enough to cut anything I need at the moment. 8x8 capacity, has a coolant pump, a really nice one too. It works very well, and I love the cooling system on this saw. And also it has a hydraulic down feed, which means that it will lift the blade on the backstroke. Something that I struggled with my homemade saw. Speaking of my homemade saw, with this saw being in the shop, being functional, being in its place, and already doing work for me, these parts are for a customer, I don't know what I'm going to do with my homemade saw. I might finish it and essentially use it for really big projects where I need to cut up really big steel. I might turn the base into a welding table or a jig table. I just don't know yet. This saw right now, it's quick. Even though it's a power hacksaw, I know there's a lot of people out there who don't like these saws because they're perceived as very slow, but it cuts through this 6-inch forklift tine. It's 6x2 hardened 4140. It cut through it in 20 minutes, which isn't too bad. Cut through 2-inch 4140 in about 5 minutes. So I did a couple of little things. I made a 12-inch base for it, 12-inch tall base for it to get it up off of the ground some. And also instead of the half-horse sort of Harbor Freight motor it came with, I put my 3/4 horse DC motor on it, and so now I have variable drive, variable speed, and I can actually use this hacksaw at twice its rated speed if I wanted to. I probably will never do that, but I could. Let me bring you in close and show you guys some of the features and controls of this saw, and talk a little bit more about it. Where it sits, this saw is sadly kind of difficult to film. But, as you can see, very heavy cast iron construction. The whole saw, which again is on a 12-inch riser, so it would be 12 inches lower, or if I didn't have this base on it. It weighs 465 pounds. It was rated for 210 RPM on the sprocket, and I think that translates to about 105 strokes per minute. Get my stool out of the way. The vise is a swivel vise. Coolant pump is under there. There's a hydraulic reservoir. When I got this saw, there was no hydraulic oil in it, but it still worked. It wasn't using hydraulic oil. The guy had water in it. It sat outside in the Pacific Northwest for, I assume, many, many years. The arm here has very little wear on it. The pads, however, the wear strips, I suppose, they have quite a bit of wear on them, and I'm probably going to make replacements out of bronze. It has a adjusting weight here, so if you want a really heavy cut, you move it all the way forwards. I don't really have to use that too much, it seems. It cuts pretty quick, pretty fine finish. I had to take off a 1/4 inch here. Pretty fine finish on it, very smooth. I did make up a bunch of these leveling feet for it that I need to put underneath it. These actually I cut on the hacksaw itself out of 2-inch bar. Each one of these is 5 minutes to cut each one of these. The blades I'm using I got for an amazing deal. I got 20 of these Atkins hacksaw blades, 17-inch, 4 teeth per inch. Fairly aggressive, but you really want an aggressive blade with a power hacksaw. Really fine tooth blades are okay for bandsaws and for very thin work, but cutting steel like that and most of what I have here, stuff like that, I need an aggressive blade. Now for thinner things where I'm not really cutting super thick steel, I do have a bandsaw. I got this cart recently for my birthday on the 10th, and I use it for storage of tools and as a bandsaw cart. I can roll it around, and if I have to cut really long awkward pieces. I'm also going to raise this saw up a little bit and make it so that I can put pallet forks underneath it and lift the whole thing and bring it outside if I have to cut a very long piece. However, as it sits, yeah, I need to clean up the shop, but as it sits, I can pass a fairly long piece of material through the saw and then cut off, say, a 4-foot section without hurting the car, and I do not want to do that. So I do need to clean out the chip tray here. It produces a very nice chip. This blade, bring it up. This blade is doing pretty good. It's cut through, made, oh, if I could focus. This blade is made probably 4 cuts in that forklift tine and 6 cuts in this 4140. And that blade, to me, if my phone weren't all blurry and out of focus, I'd show you, but it looks like it's brand new. It definitely feels very sharp still. Back here, we have the lift piston, and we have the piston that connects to the arm, and we have a little hydraulic piston that connects to an eccentric on the crankshaft. So as this pushes down, it pushes the whole arm up just a little bit. Over here on this side, once again, we have our clutch, we have gear drive which reduces the speed of the pulley, gear drive, and a automatic stop down here. This little lever here, if I pull it, I won't right now because I need 2 hands, but you pull that lever and essentially there's a ball bearing in the bottom of that cylinder that it lifts up and allows the oil to flow down. So if you want to bring this arm down, you want to get all the fluid out of that cylinder, then you can drain it all out through the bottom. You might be wondering why I bought this saw as opposed to finishing my other saw. I was pretty close to getting the other one done. I actually made a couple of cuts in some smaller forklift tine for dies on my power hammer. Well, it's a matter of skill. I simply cannot make a hacksaw that is as nice, as rigid, and that is as precise as this one is. I can try, I can forge out a really heavy frame, I can do all of these things, but in the end, the investment for me to make a hacksaw that is as good as this one is going to be immense. I'm going to go through lots of steel. I'd have to cast many components or forge them from heavy steel, which is a very expensive process. It's just not economical. Not only that, but also the people that built this They dealt with this day in and day out for years. They knew how to make a good hacksaw. They knew how to make a good saw and machine, and they had more knowledge than I do. And they had a much higher salary than I do too. So little things on this saw, like the fact that everything is in line in a single plane, or what I mean by that is the crankshaft or the connecting rod connects to the frame here in the center. It's guided up here in the center. The blade is in the center. Everything is all in the center. Things like that that I didn't think about whenever I was building my saw. Sometime in the future, I might make a video on boring out some of these, the connecting rod really, and bushing it. My grandfather gave me some bushings, and that fit perfectly on there. But again, it's really tight. There's very little play. There's maybe not a 16th, but a 32nds of an inch back and forth, which isn't great. I keep it very well oiled because of that, and it could definitely be better, but for a saw that was made in 1930 to 1940 is what I think when I think it was made. That's not bad at all. Another thing I need to do to this saw is I need to make an arm here, a mechanical, essentially a lever that connects to the frame up here and hooks onto the base down here. It came with one, but I don't really like the design of it. I don't think it's original. It basically, this saw at the moment is very slowly falling because the hydraulics are not perfect. They don't need to be perfect, and you don't want them to be. They slowly leak all the time. That's how it feeds. And sometimes you don't want it to do that. You want it to hold up and stay there regardless of how the hydraulics are leaking. And so that's what that arm does. It just simply provides a mechanical link. Well, that's been that video introducing this power hacksaw. I think I'm going to do another one on the benefits of the power hacksaw with an actual hacksaw rather than a homemade one. This saw, as I said, it cuts pretty quick for what it is. A lot of people think that these saws are real slow, but I'll save the numbers for the next video. If you like this one, please like and subscribe. It helps me out quite a bit. I love seeing people liking and subscribing. It makes me happy. And please comment. I absolutely love comments whenever people are interacting with me. I do this YouTube channel for fun and just for the community, really. And the comments are always great. Thank you for watching, and have a good day. It exploded.